I want to build a motorized camera slider, the kind that does those really cool, smooth cinematic shots. And I just ran into part of the project that I've been avoiding for a really long time. I have absolutely no idea how to make a stepper motor actually do what I want it to do. I can design this in CAD, I can 3D print it on my 3D printer, and I can assemble it. But this part, the wires, the coding, the random Arduino nonsense, I have no friggin' idea. So instead of designing anything just yet, I'm just gonna try to go and make the motor do what I want to do while it's still on the bench. If I can do that, then I'm allowed to go and proceed with actually designing the slider. So here's the parts list. Stepper motor, Arduino, breadboard, potentiometer, limit switches, wires, and my mitts. Okay, well, it's spinning. I can turn it on and off, and I can change direction, which means it officially is listening to me. I should say, I didn't write the code from scratch. I gave AI, ChatGPT in this case, a list of my parts, and it spit out a starting point in the coding process. It gave me something that mostly worked. But I still had to wire it correctly, I had to troubleshoot some of the issues that we had with the different parts, but overall, it's working exactly as I would like. Let me take a second, because that was way too easy. Turns out I forgot a really huge piece of the puzzle. Stepper motors need a dedicated driver board for it to work. What I was doing was plugging the motor in directly into the Arduino at first and wondering why it didn't work. Once I added that driver, everything came together. Now that we can actually move the motor, I wanted to control its speed. So I added a potentiometer, basically a knob that sends an analog signal to the Arduino. Turn the knob, change the speed. Simple, right? And surprisingly, it did work. When I turned the knob, the motor speed changed. Except, when I turned the potentiometer all the way up, the motor slowed down for some reason. Why is it doing this? I expected twisting the knob all the way to max would mean max speed, but in this case it was backwards. What I didn't realize was how I was mapping the values. The potentiometer sends a specific number to the Arduino in a range, and using that number to control the delay of each motor step. The smaller delay, the faster the movement. So when I turned the values up higher using the potentiometer, the delay increased and the motor slowed down. Once I realized that, it was a simple fix to update the code. I inverted the mapping, and suddenly the knob behaved as we would expect. So now I can control direction and I control speed. Next problem is teaching the motor when to stop. That is, of course, after I do a bit of soldering. Just don't tell my fiance where I got the wire. Now the real test. Speed control, direction, and limit switches, all working together. I turned it on, I turned the knob, adjusted the direction, manually triggered the switch, and it all worked. The motor stopped exactly when it was supposed to. This is where it gets exciting. Once the slider is built, we're going to have two limit switches on either end. With the toggle, which I'm going to call the bounce mode, I guess, it's going to have the carriage where the camera bounce in between the limit switches. That means smooth back and forth motion, completely hands-free. So the limit switches aren't just a stop, they're the beginning of automation. But that's not the last step of the electrical puzzle. The final step is independence. Because right now the Arduino needs a 5-volt power source and the motor controller needs a 12-volt source. If this is going to be a real tool, it needs to power itself. I already use Ryobi tools for most of the tools in the shop, so I'm gonna use a Ryobi battery. These are 18-volt packs. The motor controller can handle up to 24 volts, so that can run directly from this battery. The only thing that does need stepping down is the Arduino that needs that 5-volt source. So I added a single buck converter to bring 18 volts down to 5. One battery, clean power distribution. This means no plug into the wall, no computer tether, now it's independent. Now we get to the hard part, actually designing all the parts to bring this all together. So that means we got a lot of CAD designing ahead of us. So this slider is going to need a backbone. So we got a 600mm aluminum extrusion with a 600mm linear rail, bolted together with M3 screws and T-nuts. This becomes the spine of the slider. Before I can design anything around it, I need accurate models of all the parts that I have in the real world already. So I measured everything. Then I created it in CAD. Once everything exists digitally, I can figure out placement. With the major components in their 3D digital space, I designed the legs. They mount the motor, they mount the battery, and they tie everything together. Now with all the models created, we can throw into Bamboo Slicer, and 6 hours from now we should have all the parts and pieces to actually make our first prototype. Very exciting. And it works. The first prototype is mechanically there. With it assembled, you can see the full vision of what I was going for. On this side, we have a motor mount. It's solidly bolted to the leg, and right next to it is the first limit switch on the back. On the opposite side, we have the battery adapter, the idler pulley, and the second limit switch. The idler does more than just guide the belt. In this case, it also tensions it, since the motor mount is solid. I put a captured nut in this little rack and a long M3 bolt to go and pull it taut. As the bolt tightens, the idler moves backwards, tensions the belt. Simple, adjustable, and solid. We have the carriage that carries the camera. On one side, we have where the belt clamps to, which has little teeth marks to go and capture the teeth so there's no slipping. On the back, we have the small arm, which triggers the limit switches. So right now, the belt tracks straight, the tension stays consistent, and the limit switches stop it exactly where they should. Of course, right now these prints are PLA just for testing because it's what I had on hand, but the final parts will be PETG just to go and make it a little bit more durable. So mechanically, it works exactly as I wanted. This means we're in the home stretch. Now the electronics need to be made permanent, and we need a proper control panel. This project left a trail. Unused parts, failed prints, more soldering iron burns than I'd care to admit, but that's part of building something from scratch. This is version 1. All the parts were reprinted in PETG. They're stronger and more durable, of course, with a few small tweaks for wire management, and all the electronics finally moved off the breadboard. I designed an enclosure with a front panel that holds all the controls. Inside, we have the Arduino, the motor controller, and the buck converter permanently wired. And that wiring was the hardest part. To be honest, I've been soldering since I was 10 years old, but never with components this small. It took longer than I expected to develop a workflow that gave me solid connections, but once it was wired up, it worked exactly like the breadboard version. There's access on the side of the control panel to update the Arduino if I need to change the code, a hard-mounted fuse, and a master power switch. The cable management, though, is acceptable. Nothing's dangling, it'll get better eventually. And in the middle of the spine, we have a tripod mount, so it can be used in multiple configurations. It is just over 4 pounds without a camera, and really, there's a lot of room to grow. Maybe tapping into the 5-volt power to go and charge the camera as it's going, or maybe adding a panning head, which is a little bit over my head at the moment. But for now, this gets the job done. It makes filming more interesting, and it taught me more about Arduino-controlled systems than any tutorial could. Going into this project, I really didn't know anything about Arduino or camera sliders. I never looked up a tutorial, even though there are plenty out there now that I look. I just treated it like one puzzle to solve. And this is only the beginning.